Okay, again, I'm going to recommend if you have not done these problems yet that you try it on your own, see how far you get, even if you're wrong. It will be a lot more beneficial to you if you learn from that than if you don't try it at all. Okay, how many kilograms of uranium would be required? So that's what they want to know. So kilograms of uranium is going to be okay, so which quantity do you start with? Energy needs for 1 year. So the final units, oh, and I did the wrong color. Goodness gracious. 1 year. Okay. All right, so let's find what we need. We know we're going to start off with a year. So let's see what we can do with 1 year here. And let's see, it's asking us for U.S. energy needs. Okay, so 1 year of U.S. energy needs is 1 times 10 to the 20th. So 1 year U.S. equals 1.0 times 10 to the 20th joules. Okay. Let's see, the one with uranium. Okay, so I have 1 kilogram of uranium is equal to 5.6 times 10 to the 13th. And again, I'm just taking that off of this chart. The uranium, 5.6 times 10 to the 13th. Okay, so now we just got to get started. All right, so I'm going to use the one that has a year here so I can cancel this out. That's going to give me 1.0 times 10 to the 20th joules. Notice I put the units. Make sure you're putting the units. Okay, so I have joules up here. I need joules down here. Using my other conversion factor, 5.6 times 10 to the 13th, and its equivalence is 1 kilogram of uranium. Okay. All right, so the joules are gone. My kilograms of uranium are what I want. So now I just have to do my multiplication. So this gives me 1.0 times 10 to the 20th divided by 5.6 times 10 to the 13th. Again, I want to, if I'm doing it in my calculator, key it in just like this. I don't know what the answer to this one is. So let's see. 1.0 times 10 to the 20th divided by 5.6 times 10 to the 13th. And let's see, what do I get? Okay, well, my exact answer is 1,785,714, let's call it 0.3 kilograms. Okay. If I want to estimate this, I would call this 1.8 million kilograms. All right. Okay, let's see here. All right, if you could generate energy by fusing hydrogen, how much water, okay, that's what I'm going to end up with, how much water in liters is required to supply the energy consumed worldwide in 1 year? All right, so let's see what we've got here. We've got, we're starting here with 1 year. Okay. Now clearly throughout all this I am going to have 2 conversions. Because I've got to get rid of the years, the only way I can do that. And I'm going to end up with liters of water. Okay, so what does that tell me? I need years down here. I know I need liters of water up here. So let's see if we can find our conversion factors. Okay, so 1 year for the world, and I'm abbreviating, is equal to 5.3 times 10 to the 20th joules. And if I'm fusing hydrogen, I know that 1 liter of water fusion is equal to 6.9 times 10 to the 13th joules. Okay. All right, so here's what I've got. I know if I have my 1 year here, then I can, its equivalent is 5.3 times 10 to the 20th joules. So my years are gone. Now I've got to get rid of my joules. So I know that 6.9 times 10 to the 13th joules is equal to 1 liter of water. Okay. All right, so everything's gone except the units that I wanted in my answer. So this becomes 5.3 times 10 to the 20th divided by 6.9 times 10 to the 13th, which is equal to that's a big old number. All right, and I didn't leave myself enough room here, so I'll just put it here. Sorry about that. So it's 7,681,159.42. Or I could say, let's do 7.7 million. Or I could say 7.7 times 10 to the 6, because 1 million and 10 to the 6 are the same thing. And of course, this is liters of water. All right, our very last topic for this is comparing units. And again, this is something we've done before. So if you want to compare 2 quantities with the same units, always larger over smaller. Okay, so let's compare the energy released by burning 1 liter of oil with the energy released by metabolism of 1 candy bar. Okay, so 1 liter of oil is 1.2 times 10 to the 7th. A candy bar is 1 times 10 to the 6th. So the larger one, it has the larger exponent, is going to be the 1 liter of oil, and the smaller quantity is going to be 1 candy bar. Okay. Okay, but what we're comparing is the energy for each of these. So we're looking at the energy in joules. So 1 liter of oil is equal to 1.2 times 10 to the 7th. And a candy bar is 1 times 10 to the 6th. So my larger quantity is going to be 1.2 times 10 to the 7th joules divided by 1 times 10 to the 6th joules. And what I get when I do that division is 12. So I know my larger cup, 1 liter of oil, releases 12 times as much energy released by 1 candy bar. Okay, have a good weekend, everybody.